Geometry students, we are going to enter into the world of no calculators, specific triangles. You, in your mathematical life, need to understand the side lengths of a 30, 60, 90 triangle, as well as a 45, 45, 90 triangle. And then you need to be able to scale the 30, 60, 90 and the 45, 45, 90 triangle. And the reason why is because it's very easy to show the side lengths of a 30, 60, 90 and a 45, 45, 90. It's very easy to prove the relationships of them. And therefore, it becomes very easy to scale. We start with the equilateral triangle where all of the angles are 60 degrees. If I drop down a line, I split this bottom thing in half. If this starts as 1 and this starts as 1 and this starts at 1, I cut this in half, this becomes a half. Then I use the Pythagorean theorem, and you don't have to do this. Rather, you do have to know what the side length is going to be. And if I take a half and square it, I get a fourth. If I take 1 and square it, I get 1. And I get b squared is equal to 3/4. And I get b is the square root of 3/4. And we are going to write this as the square root of 3 over the square root of 4, which is 2. And this becomes the 30, 60, 90 triangle that we know. So we are ready to scale this 30, 60, 90 triangle. There's another 30, 60, 90 triangle that we might want to scale, and that's this triangle doubled. And when you double this triangle, you don't have fractions anymore. Let's pretend it's double the size. But you will have just 1, 2, and root 3. Okay? And again, like if you square this, this is 4, and this is 1. You subtract, you see 1 squared plus root 3 squared is 2 squared. And this is what you got. So if you put things on the side, you can see you have a short side, you have a longer side. If your hypotenuse is 1, that's this triangle. You get this and this. If you got this short length is 1, you can see that you get this is root 3 and this is 2. And now here's the tricky thing. If we have this is 1, well, like how do we go from root 3 to 1? You could take 1 and divide it by root 3. We could divide everything by root 3 or multiply everything by 1 over root 3. So I could take 1, multiply 1 by 1 over root 3. I get 1 over root 3. I can take 2 and multiply it by 1 over root 3, and I get 2 over root 3. These are 3 triangles you could really scale. We usually just stick to these 2. Okay, we stick to these 2, and the third one we don't really memorize, but you either have this one memorized or you have this one memorized, and you work with that. So with the 45, 45, 90, again, we didn't really start with an equilateral triangle. We started with a 45-degree triangle, and we know that if this is 45, this is 45, and it's an isosceles triangle, which means this side length and this side length are the same. This length is 1. If you use the Pythagorean theorem, you got a squared plus a squared equals 1 squared. Which means 2a squared. Oh, this is my favorite. It's the C of Christmas album. Divide by 2, square root. Let go. These are the two 45, 45, 90 triangles that we can use to scale. The background music. Okay, so now it's like our responsibility to be able to find side lengths of a 30, 60, 90 triangle that are missing. Because we already have one that we have to kind of know. You have to memorize and then be able to scale. Whether you start with your 30, 60, 90 triangle with 1, a half, and root 3 over 2, or you start with your 30, 60, 90 triangle with 2, sorry, 2, 1, and root 3. It doesn't matter. Like, if you want to scale this one, you can see like 4 divided by a half is the scale factor, which is 8. Can scale this by 8, or you can scale this by 4. So this times 8 is 8. This times 4 is 8. Root 3 over 2 times 8 is 8 root 3 over 2, which is 4 root 3. Or this times 4 is 4 root 3. Take this down because of copyright infringement. Evan! Well, that was fun. We're just scaling triangles that we have to know. Now, like, yeah, you have to memorize it. Either memorize this one or you memorize this one. Depends. Maybe you memorize both or you memorize one and be able to adjust to get the other one. Here, this would be like 1 divided by 2 is like you would divide by 2 to get from this one to this one. This is multiplied by 2. Here, this one's a little bit trickier. You multiply by root 2 to get root 2, 1, and 1. But no matter what triangle you see, if it's got 30, 60, 90 degrees in it, and I ask you, what is the sine of 60? You don't need a calculator anymore. You have the opposite over the hypotenuse. That's root 3 over 2. This is the sine of 60 if we're talking about a triangle with a hypotenuse of 1. This is the cosine of 60 if we're talking about a triangle with a hypotenuse of 1. And it doesn't matter if you're talking about the bigger triangle with a hypotenuse is 2, double the size. What's the sine of 60? Root 3 over 2. What's the cosine of 60? 1 over 2. This is what we're talking about here. What's the tangent of 60? Root 3 over 2 divided by a half, or root 3 divided by 1. Root 3. What's the sine of 45? Well, the sine of 45 would be the opposite over the hypotenuse. The opposite is 1 over root 2. Hypotenuse is 1. Opposite over hypotenuse. This is the sine of 45 if we're talking about a triangle with a hypotenuse of 1. If you want to make this 45, 45, 90 triangle the 1, 1 root 2, then yeah, you can see like adjacent over hypotenuse or adjacent over hypotenuse would always be 1 over root 2. What about the opposite over the adjacent? The opposite over adjacent? Oh, 1. Since it's a 45, 45, 90 triangle, we're going to have to see that the side lengths are the same. So the ratio is 1 to 1. What about the sine of 30? Sine of 30. Well, 30 is up here. 30 is up here. Oh, the sine of 30 is going to be the same as the cosine of 60. You remember that idea of the complementary angles, the trig functions are switched. The sine of 30 would be 1/2. This is the sine of 30. What's the cosine of 30? Oh, root 3 over 2. Root 3 over 2. What's the tangent of 30? Now, this is a little bit tricky. It'd be 1 over root 3, or 1/2 divided by root 3 over 2. Now, what if I give you this and I ask you for A and B? It's a little bit trickier. See if you can figure this out. Well, if this is our 60-degree triangle, this would be our longer side. This would be the 1/2 splitting of that. We can see to go from 1/2 to 2, 2 divided by 1/2, that's the same as 2 over 1 times 2 over 1. That's times 4. Okay, we know that root 3 over 2 times 4 must equal 3b. Okay, this side length has to be 2 root 3. I'm going to go ahead and divide both sides by 3, and I get b is 2 root 3 over 3. This side length has to equal 4. So A has to be 4/6, which is 2/3. Why? Because like we take our smaller triangle and we scale it by multiplying by 4. What about this situation? This is easier. If this is the 60 degree, this is the root 3 over 2. This is the half. I'm taking the 1 and scaling it by multiplying by 8. Well, so 1/2 times 8 is 4. 3a has to equal 4. A has to equal 4/3. Root 3 over 2 times 8 would be 4 root 3. 4 root 3 has to equal 4b. Divide by 4, you get b is root 3. Now, a lot of this, guys, is being able to deal with fractions, but hopefully you're capable of doing it. Okay, let's take our 45, 45, 90 with the hypotenuse of 1 and try to work with this. This will be a little bit trickier, but we can see the scale factor is 12. Just multiply everything by 12. So I get this is equal to 12 over root 2, and this is also equal to 12 over root 2. Now, if I divide by 3, this might seem weird, but that's the same as multiplying by 1/3, which becomes 4 over root 2. Same here, dividing by 4 is the same as multiplying by 1/4, so it becomes 3 over root 2. That should be a root 2. Dividing by 4, same as multiplying by 1/4. You get 3 over root 2. Same thing here. Maybe this one is going to be easier to start with. This one might be harder to deal with, but let's just do it just in case. I will let you know that it would be easier if you used the 1, 1 root 2 triangle, the root 2 times triangle. That's multiplying everything by root 2. Because I would take that and multiply by 6. But let's say we don't. I can see the scale factor would be 6 divided by 1 over root 2. That's 6 times root 2 over 1. That's 6 root 2. So I got to multiply everything by 6 root 2. So 1 over root 2 times 6 root 2 becomes 6. I mean, it's honestly, I don't know why I did this. It's a 45, 45, 90. So obviously this is also 6. So A is equal to 3/4. This is easy. 9B has to equal the scale factor, which is 6√2. It's good to see we're stacking even on the dreariest of days. Divide by 9, divide by 9. B is equal to 6 divided by 9, divide the top and bottom by 3 is 2/3. 2√2/3. Equilateral triangle has a perimeter of 18. If it's got a perimeter of 18, each of the sides has to be 6. What is the height of the triangle? Well, if this is 6, you know this is 60 degrees, you know this is 3. What is that going to be? Oh, I forgot. Okay, 1√3/2, 1/2. Okay, multiply everything by 6, which means multiply √3/2 by 6, and I get 3√3. 8 to 10. What's the perimeter? Okay, so we start with the hardest side, which is the longest side, the √3/2 side. And we got to figure out the scale factor. 10 divided by √3/2 is the scale factor, which is the same as 10 over 2√3, which is 20/√3. Okay. That means this length is 20/√3 because that's the scale factor. And I'm taking this 1, which means all of these are 20/√3. Now, what is the perimeter? I need to add these together. Well, if you add 20/√3 3 times, you are tripling 20/√3. That's 60/√3. Okay, if this is a 45, 45, 90, then this is 10. You can find this side, or split this in half. This side length is the same as this side length. If you want to start with your 1/√2, 1/√2, or if you want to start with your 1/√2, it's probably easier, doesn't matter, to use this. Know that it's the scale factor of 10. Take 1/√2, multiply by 10, and you get 10/√2. Cool. Is the perimeter. So if this is 20, this is 20, which means this should be 20 as well, which means this is 40. So there's many ways to do this. You can find this side length using your smaller 45, 45, 90, or you do whatever you want. It's fresh for so long. It is probably easier to use this triangle with 1/√2 and multiply it by 20 to get that this is 20√2. Why? And this would be 40. You could also figure out that the scale factor for this triangle is 20 divided by 1/√2, which is 20 times √2/1. So it's 20√2 as the scale factor, getting that. If we add everything together, this is 20, this is 20, this is 40. But then we have to add two 20√2s, which is 40√2. You cannot add those together. That's just going to be 40 plus 40√2, and that's going to be our answer. Okay. So just scaling triangles we know, but you have to know the triangles. I hope you're not copying this stuff down. And we got a review day than the test. Peace.